Good evening and welcome from a kind of damp San Diego this evening. My name's Gary Hawkins. I've started the stream just a little bit early here, just so that we can check that the audio quality is going out okay. Thank you, thank you. Um, and We are having a few technical problems here, but we are at least functional. But you would kind of laugh if you were looking at us currently. We've just been given a whole bunch of napkins because our computer equipment is disappearing in water here. There's so much humidity in the air, and at the moment the telescope lens is somewhat fogged up. But hopefully that will be okay as well. Um, we have about 33 people on board, so welcome. I will do a formal introduction in a couple of minutes. Can somebody in the chat window please give me an indication that we are good volume-wise and that you can hear me okay? That would be very helpful. So I just want to check that we are good from a volume perspective. If somebody could let me know that things are good, that would be fantastic. We have about a minute to go before we officially start here. And I'm hoping by the time that we do officially, okay, so we're all good. Thank you very much for that. Really appreciate the fact that you can hear us. For those astronomers out there, I'm sure that you will know some of the challenges that you get with humidity and dew. And I can tell you we're closer to the ocean than I normally operate, and it is just surprising how humid the air is and how quickly this is just putting water everywhere. Hopefully everything will just keep going. We will start the show. We will probably at some point, we've got a hairdryer coming down. I know this will make you laugh. We've got a hairdryer coming down to help clean the dew off the lens. So I'm sure at that point things will get a little better. But in the meantime, as soon as we get to 8 o'clock, I will start the sort of introductory presentation, introduce my colleague who's up here today, and talk a little bit about our location and hopefully what we're going to see this evening. And we now have 51 online. This is a fantastic turnout. So I'm hoping that we can put on a good show for you guys. And if you've got questions while we're talking, please type them in the chat window. We'll try and keep an eye on those. Dave will be monitoring the chat. Actually, are you monitoring the chat window, Dave?
I can see it.
Oh, okay. So you can see the chat window.
Yes.
Okay. So Dave is monitoring the chat window and will probably chime in with some answers as well. And there is about a 4-second delay or so between me talking and you actually hearing it. And then there's at least a 4 to 8 second delay for you to type a question in it to come back to me. Even when you do ask a question, please just bear with us because it will take us a little while to see that question and then to sort of jump in and answer it. Okay, so we kind of hit 8 o'clock. So I am going to bring up my presentation here. I've got a few things just to organize on my streaming software, and then we can start. It's kind of interesting just clicking on things at the moment because, as I said, with the moisture, I'm not actually sure that the computer's going to respond. So, what is going on here? Right. Hold on 1 second here while I just try and figure out what's going on. Okay, let me try that again. Oh, 68. So I must say, this is the largest number of people I've ever had on a live stream before. So that's fantastic. And as soon as this computer responds to me, I will start this slideshow off. Okay, what is going on here today? All right, well, okay, I guess we're gonna have to do this a slightly different way. I was hoping to bring the slide screen up, the slideshow up full screen, but for some reason, I guess it must be the evening. Are we doing this on Friday the 13th?
I had the full screen.
Oh, you have a full screen, Dave. Oh,
I do.
oh, well, that's kind of weird. Well, I don't have a full screen on the stream, so I guess we're just going to have to do it this way. So anyway, by way of introduction, my name is Gary Hawkins, and I'm with my colleague here from the San Diego Astronomy Association, Dave Decker. Dave Decker is the Public Outreach Director for the San Diego Astronomy Association and has kindly done all the organizational stuff associated with getting us up here this evening and working with the Mount Helix Foundation, who are hosting us. So Mount Helix is one of the iconic landmarks in
East County.
in the East County. And sorry, I'm just pressing keys on this computer and nothing is happening at times. It's very disconcerting. So Mount Helix is one of the iconic sites in the East County of San Diego. And it is actually a privately owned park. It's run by the Mount Helix Park Foundation, which is a 501c3 nonprofit. And it's open to the public 7 days a week. And it's got a beautiful amphitheater here, incredible views of the city, and it also has a very large cross memorial at the top. And we're actually just sitting below the cross. I was kind of hoping this evening that we would be able to swing the sort of, I have an E-finder on my telescope, that we would be able to show you the cross, but as it happens, the position that we've chosen for tonight's live stream, the cross is actually completely masked out by trees, so I'm not going to be able to do that. We are coming from, like I said, near downtown San Diego. We're actually a little bit to the east of downtown, and we are in very light polluted skies here. Technically known as Bortle 8 skies. That means to say we've got a very high degree of light pollution. When you look up at the night sky, you can't see too many stars. But with the technology that we're going to be using tonight, we're hoping to pull out a few of the sort of celestial wonders that are up there for you to see this evening. The setup I'm using today is a 8-inch Schmidt Cassegrain telescope, a relatively small telescope, and this one's actually quite old. This is circa 1988, so it's 22 years old. It's done a lot of observing, primarily with its previous owner. But behind that, we have what's called a focal reducer that allows me to have a slightly wider view of the sky. I then have a light pollution filter that helps me to knock down that light pollution that I was talking about a few moments ago. And most importantly, I have an imaging camera that sits behind that. It's a 9-megapixel imaging camera. To give you an idea, it's probably about half the resolution of your DSLR, or certainly half the sensor size of a standard DSLR. And we are going to be taking images from the camera that we're going to be collecting in what's called a subframe. We're typically going to be doing 12-second subframes this evening. And we're going to be putting this into a pretty neat piece of software called SharpCap Pro. I'm not wishing to get too technical on you, but essentially what this does is it will take each one of the incoming frames that we have, it will do a star alignment, it will then add these frames together so that the background noise drops away and the image comes improves in its look, and then I'll apply some sort of final histogramming and everything on it in order to show you the image as best as we can this evening, considering the conditions. I'm not going to go through the equipment list. I'll just leave that up on the YouTube stream if you want to come back to the stream later and take a full look at the hardware and software configuration. It's on this slide. And then at this point, I'm going to hand it over to Dave to say a few words. Dave is going to be helping me with the commentary this evening. And while he is saying a few words, I'm going to bring us on to our first target. So, Dave.
Okay. Hopefully, this mic is working. And welcome to everyone. This is the first official reopening of San Diego Astronomy Association outreach events. We have done lots of electronically assisted astronomy at our hands-on events, and those of you that have in the club that have done that, we appreciate that. So now we're trying to take that to the next level and put it on this live stream here. So welcome aboard. We really appreciate everyone responding to the websites from Mount Helix Park and from the SDAA, from Facebook, wherever you found out about our event. So welcome to the resurrection of SDAA outreach. This is pretty much an experiment, moving to an environment where we have not.
I think we may have lost your audio there. Let me just check. Okay, Dave, so I can see your audio is working. I think you just need to be maybe a tiny bit closer to the microphone there.
Okay, I'll try a little closer. So this is an experiment, moving away from an environment that we're used to working in, onto a host network and a location where we have to move all the equipment. So we will see how it goes. We will certainly not guarantee perfection, and we've already had a few challenges based on the high humidity up here, and so we'll see how this goes. Gary has done a great job of developing the protocols he's using tonight, and he's been using those protocols from his home, and now moving away from home to the top of this mountain is the next big step. So we'll see how this goes.
Yes, Gary may well be going back to his home again, because not only is it dry over there, I am 30 seconds away from solving technical problems where I could just go and get a cable from the house. It's a lot drier in the East County where I live, and yes, this is definitely a challenge tonight, and I am so hoping that this hairdryer is going to turn up here, because I can see that we are having a few issues. Yes, we're basically having issues here with our telescope. A lens has basically completely dewed over here. So we may just have to do some single shot images to start with, and we'll go from there. And yes, and we'll go from there. Oh dear. Right, so by way of, oh, we have a hairdryer, so this could get us out of a few problems here, and I'm sure everybody is chuckling away there on the. Yes, Lester, I do have a dew shield, but believe me, we are close to 100% humidity here, and so consequently, it's just not working. And to be honest, we also had a few technical issues when we first got set up, and so the dew shield was off longer than I would have liked, and so that allowed the dew to start building up, and of course at that point things got a little bit hairy. So just while Dave is getting the hairdryer going here, and I'm hoping to hear that whirring in a couple of moments, we are going to be looking at a number of mostly targets, particularly early on in the presentation, that are in our galaxy, so the Milky Way galaxy. So we're going to be looking at primarily star clusters, open and globular star clusters. We are going to be looking at a number of nebula that are out there, and we'll kind of give you more information on that as we go along. And then towards the end of the evening, we're actually going to start looking outside of our own galaxy, outside of our own galaxy, the Milky Way, and we're going to actually see if we can see a few of the galaxies that are in our relatively near vicinity. And at some point during the day as well, or the evening as well, I'm also going to discuss the concept of light years and distance and so forth and so on. For those of us, or for those of you that are not astronomers, then I think it's kind of helpful to get an appreciation of just how big things are out there. So Dave is working away with the hairdryer, and I'm hoping that that is probably enough. So I'm going to clear this stack here, and I am going to see if this program will start actually collecting.
Our screens aren't showing. It's still in the PowerPoint.
Sorry?
It's still coming through. It's still in the PowerPoint.
Oh my word. Okay. No, so this is the live stream. I've got the live stream up monitoring on YouTube here.
Now it's up. It just popped up.
Okay. So I'm hoping that everybody has the stream is holding up here. If you guys are actually, because I've got a monitor running here, so if you guys want to log off on your end so that we can take the load off of the network, that would be great, because that would be helpful. And I've got Hector's asking the question, why do we need the hairdryer? So we have a 8-inch telescope here that has, I think we're good, Dave. I think so. I'm hoping so. We have an 8-inch telescope here that's got a large glass plate at the front of it. And unfortunately, as the temperature drops with a very high humidity, that causes dew or moisture. It basically films up to form on the front of the lens. And of course, that means to say that we can't see as clearly. So, okay. Okay, so Kathleen added, this is so dramatic. I'm not sure whether it's dramatic. It's certainly giving me a little bit of heart failure here. Right, so let's see if we can, let's find out what's going on here. Okay, so I'm resetting my stack again. And I'm trying to form our first image here of a globular cluster called M15. And if we can, yes, okay, so that's at least partially promising. And I can honestly tell you nothing is working with my mouse and things here. I am clicking things and my mouse is not responding. I think I need a beer, guys. Anybody got a stiff drink or a beer? I am going to need a drink very shortly. Okay, so we have our first image forming. And we're still not stacking here. What is going on? All right, let me just check a couple of things here. Oh, man. All right, but at least we have our first image, albeit that the image, unfortunately, is not getting any better. This is the globular cluster M15. What you're actually looking at here, and thank you for the wow there, Hector. Believe me, if we could actually start getting some of these software programs to work here, this object would definitely be a lot better. But you can see here that we have a aggregation of stars with a very dense core and many thousands of stars that are surrounding it, and depending upon the precise globular cluster that we could be looking at. We might be looking at 10 or 15,000 stars, maybe more, in fact. Could even be into the millions for perhaps some of the largest globular clusters. And just to give you an idea of field of view here, so that it allows everybody to sort of get a sort of perspective. The field of view that I'm actually showing you is 1/2 degree by 1/2 degree. That is almost precisely the size of the moon. So if you could imagine the moon, fitting in circular in this field of view, if we were looking at the moon, we would get that. So this is actually quite a large target. If you were actually able to see this target in the night sky, but it would actually appear, you know, quite spectacular, certainly larger than the planets that we can see out tonight. I've got Mars in front of me, and I've got Saturn and Jupiter disappearing behind me. Certainly a much larger object than any of these planets. Right. Okay. So we are still. I'm just gonna try and reset this stack again, because what happens here is what you're seeing at the moment is a single 12-second image, and that's showing us a good amount of detail. But for some of the other targets that we're gonna hopefully be looking at this evening, which are much fainter, we are going to need to take. Okay, Pat, let me take a look at what's going on over there. Maybe I have my gain. I usually should be fine on 400. I'm not understanding why that's quite not stacking at the moment, but I'll just reset my stack here. I don't know if you caught the original part of this, Pat, but we were having problems, really bad problems with dew. And the telescope completely fogged up. And we've managed, I think, to clear that now. But for some reason, okay, so the first frame comes in, as you can see, and I'm now hoping that it will take the second frame, which is just coming in now, and stack that frame. Okay, let's see if this works. No, I'm not even stacking. Oh man, I think we are suffering this evening from just too much water has got into these electronics. I am struggling to keep control of these programs at the moment, and normally these run without any problem at all. So again, we've grabbed our first image, and I am now hoping that the second image. Okay, let me. Okay, so actually it took the second image, so that's good. You can see the number of frames that it stacks here. Okay, it's taken the third image, so that's positive. Now, as long as this number continues to increase, as I hope it, okay, it's taken the fourth image. So we are now slowly improving this image, and I will be able to improve it a little bit more in a few moments. So in order to improve the image, I've got some histogram controls here, and I can move these around. I'm not going to get too technical this evening and describe exactly, well, basically what I'm doing is I'm moving the black level, the mid level, and the white level. So if you're a photographer, these are some of the controls that you would have for basic changing the parameters of an image. So I'm basically changing my black level here. I'm going to make that a little blacker. There we go. And I'm going to bring up that. Yep. Okay. And I'm going to pin that there. And I'm going to bring this image up full screen, hopefully. Come on. Okay. So I think we have, at last, a fairly good rendition of M15. Would you like to add any technical details there, Dave?
I think you've done a great job of describing globular clusters. For those that don't understand the difference between a globular cluster and an open cluster, they're completely different things. The globular cluster, for the most part, we believe is the heart or the center part of a small galaxy which has intersected the Milky Way. And for the most part, the outer stars have been stripped off, and these small galaxies actually end up in orbit around or through the Milky Way, and each time they pass through the plane of the Milky Way, they have more of their outside material stripped off. So we believe that they're actually captured because the orbits of globular clusters are not in the plane of the galaxy. They're at a high inclination to the plane, which means they were not, or probably not, created at the same time as the rest of the galaxy was. So we believe it was captured as they were captured gravitationally coming in from a different angle. So M15 is one of many globular clusters that presents very well. It probably has 300,000 or 400,000 stars in it, and it's hard to believe that we can see that many stars in a small area of space. These stars are also old stars. For the most part, they're 10 to 13 billion years old, so these are not new stars. So most globulars are pretty much the same kind of a thing. They have different sizes and shapes and different orbits. Gary?
Fantastic. Appreciate that. And thank you so much, Christina. Yes, we've finally managed to pull a decent image out of this. And I think now I've zoomed in a little bit. I brought up a 50% zoom now on the globular cluster. And you can really see how the stars group together tighter and tighter as you get towards the central core. An incredibly impressive object in the sky. And I think, Dave, we're probably looking at maybe 60 to 80 globular clusters out there, or is it may not be that many?
I think there's actually maybe more, but I'm not sure how many we've found actually documented in the Milky Way. We do know that there are globular clusters in other galaxies as well, which is a whole nother topic because they're much farther away. But it is a fairly small number compared to stars, etc. So I'm not sure what the exact number is.
Okay, fine. And Charlie, yeah, from a technical perspective, I'm using a ZWO ASI 533 cooled camera. It's a color camera, 3008 by 3008 pixels, and the pixel dimension is 3.75 micrometers, which is about the same as you get on a regular DSLR camera. These cameras that I'm using here are specifically used for astro imaging. This one has a cooler built in as well, and that allows me to capture less background noise. Although for the type of astronomy that we're actually looking at this evening, I probably don't need that cooler in play. So anyway, that's our first target for this evening at 7:15. The stacking software now appears to be working, and now we're going to navigate our next technical challenge. Okay, you want me to go to M52? Okay. All right, so Dave has asked me to go to another target called M52, and I am just going to bring that up. Actually, the corrector looks fine at the moment. Yeah, I think the corrector looks fine. Actually, if you could dry mount the computer would be really helpful, because the computer is just, this is a mess. Okay, so we are going to go to another target called M52. This is an open cluster this time. So we're not going to see this a vast collection of stars in this globular format. We are going to see a more scattered renditioning of stars. Now, one of the other challenges that we're going to face this evening is that my software... And if you can see the computer screen at the moment, if looking at the YouTube channel, you will actually see a big square that's moving across the sky map that I have on the currently up on display. That is the telescope slewing to the next target, which is hopefully M52. And I was just saying, one of the error problems that we've encountered this evening was I usually have a very clever piece of software on here called a plate solver, which allows me to point the mount in approximately the right direction, and then do what's called a plate solve, and it works out how far I'm off, and it corrects the mount so that the target appears precisely in the center of the screen. Of course, since as you know, we're having some problems here, the plate solver has decided it doesn't want to play this evening, and so we've had to go back to the more traditional method of doing a multi-star alignment with the mount, which means to say my mount is not as accurate. But that being said, we will persevere here, and hopefully we will see if we can take a look at this next target, and I'm just going to have to do things manually as opposed to is that my target up there, Dave? Okay, does that look like it might be? Okay. Yes, let me, I gotta use a different, yeah, okay. So as you can see here, this is the difference between using and not using a plate solver. If I had, if the plate solver was working, I would be able to click this little button down here, and within about 30 seconds, the mount would magically move onto the target. Unfortunately, that isn't going to happen this evening, so I am going to have to manually drive the mount with these controls down here. So I can at least see my target, so that's good. I'm going to bring this down a little bit so that... Okay, and I'm now going to move the mount. Okay, so I'm going to center that up this way. So that blurring that you can see on the screen is the mount just being nudged across. So I'm nudging it across to the left, and now I'm going to drag the image down. Hopefully I'm pressing the right, there we go. So I'm now going to drag that image down the screen so that we get it in the center of the screen. Okay, so we're coming down, I've got my mount set up quite slowly here. I might actually just change the tracking rate in a couple of seconds so that it doesn't take quite as long. Yep, okay, so no, I'm not going to do that, so I'm going to stay there. So let me just bring that down just a smidge more. Okay, so we're approximately centered. So this is an example now of an open star cluster. So I'm going to reset some parameters here because obviously, well, not obviously from your perspective, but obviously from my perspective, I'm not operating in the way that I would normally operate here. So I'm having to juggle some parameters here. Hopefully I can get this right each time. So I am now got my target centered. I'm going to turn my live stack on. I am going to clear my previous stack, which was M15, and we're now looking at the open cluster M52. Okay, great. So we have the star cluster. So I'm just gonna let a couple of images gather here. They take about 12 seconds per image, and I'm just gonna hand it over to Dave to give you a little bit more information about M52.
So M52 is a typical open cluster. We just looked at a globular cluster, and like I said before, it is a completely different thing. An open cluster is what we see after most of the star forming time period occurs in a star forming cloud or cloud of nebulosity. So when that cloud of nebulosity begins to form stars, those stars are formed like a group or a large family of stars. And once they've mostly consumed the available gas in that gas cloud, they begin to interact with each other gravitationally. Some of them are thrown out, some of them are attracted. Lots of things happening in that cluster. But eventually they move apart into a larger area of space with less nebulosity, and we call that an open cluster. So M52 is a typical open cluster, couple of hundred stars probably. I'm not really sure of the number. And I believe it's 4,000 or 5,000 light years away from us. And as the cluster ages, the stars will age themselves, and the distance between the stars will increase, and the cluster will get larger. So originally, when they first cluster up, they're grouped together towards in the center of that original nebulosity, and then as it consumes that cloud, they spread apart. So I don't know the exact age of this particular cluster. I'm not sure anyone knows, but that's pretty much what we see. And
Yeah, okay.
look at it.
And one of the other things, the significant differences you often see between an open and star cluster is the color of the stars associated with the two types of cluster. The open star clusters tend to be star clusters that are quite young, and so the stars often tend towards the white and blue, whereas the globular star clusters are generally very old objects. They're kind of the grandfathers, if you like, of the celestial sky, and so they tend towards more red stars. As a star goes through its evolution, as it comes towards the end of its life, it starts to shift towards the red end of the spectrum. And so you'll find that often the globular clusters do have a slightly more color shift in that direction.
I might make one comment, Gary. I just checking here online, the M52 has an average age of about 35 million years. So that gives us an idea about the average age of the stars, and that's somewhat young for for small hot stars. So just wanted to pass that on.
Right. And actually, that's another interesting point as well. And I've actually got a couple of slides that I'll probably bring up in a little while. Probably we'll get a few more images up on the screen before something else goes wrong here. Rather than show you slide images that I can show you at any point. But one thing that to appreciate here, particularly for the non-astronomers in the group, is that you are looking back in time here. We are, as Dave said, this object is about 35 million light years away.
It's about 4,000 or 5,000 light years
Oh,
away.
Okay.
And about 35 million years old.
Okay, so 4,000 or 5,000 light years away. So what we're actually looking at here is the light that left this open cluster 4,000 to 5,000 years ago. So 2000 BC, something around that time. So because light travels at a finite speed, which happens to be very quick, but because we're talking about such immense distances, not only in our own Milky Way, but also when we start considering galaxies beyond our own Milky Way, because it takes light this finite time to travel to us, you're actually looking back in time. And at the moment, we're looking back at an object where the light actually left that object about 4,000 to 5,000 years ago. So things could have changed up there. They probably haven't, because things don't change that rapidly or typically in space. But you are looking back in time, which is kind of cool. Nice to see you on, Mike. Thanks very much for joining. I was actually on one of Mike's live streams last night. He is based out of Death Valley, does some fantastic stuff on YouTube as well. He's been looking at galaxies recently. So if anybody's got an interest in galaxies, please look up Mike Jerry there on Cloudy Nights. He is running a number of live streams as well, looking at galaxies. And okay, Dan, thanks. I'm not sure where the insanity is here, whether it's with the people that are producing this or the fact that this is a pretty cool star cluster. But yes, pretty insane images. Very cool. Thanks for doing this. Nice to have you on board this evening, Tom. And we have about 140 people online, which is pretty cool. Fantastic participation this evening. And if you guys just want to, type where you are, just so that everybody on the stream gets a feeling, feel free. The chat box is there, and for exactly this purpose. Okay, so Dave tells me that we're going on. Yeah, we're. Okay, so we're going to hit another target here this evening. So we're going to go to a target called NGC 891. Oh, whoops, I need to.
Galaxy.
Yeah.
Edge on.
Yeah, I imaged it the other night. Okay, so.
It should be right about up there.
Oh, it's pretty low. No, it's probably good at the moment. Okay, so we're going to move on to our third target of this evening. We've seen so far a globular cluster, an open cluster, and now we're actually going to look beyond our own galaxy. So we're going to be looking through our galaxy, which are, when you see stars in the images that we present this evening, those are going to be stars in our own galaxy. When we actually look at galaxies beyond our own galaxy, so beyond the Milky Way, they are so far away, the galaxy is so far away, that you won't actually see individual stars. You will actually just see, oh yeah, I've got it. You will actually just see light, which is basically the aggregated light coming from all the stars within the galaxy. So this next image, which is going to be a very interesting galaxy called NGC 891, when we start to form this image, and I can actually see the galaxy on the screen. I'm not sure if those of you out there can actually see it, but my eye is kind of trained at, or at least it recognizes these things. So the galaxy is actually right here, not quite center, but I don't think I'm gonna move the mount. I'm probably just gonna let it form there. So the stars that you see in this picture are actually stars in our own Milky Way that we're looking past to see this galaxy beyond. And I'm hoping that Dave's going to tell me how many million light years this galaxy is.
The distance, according to Sky Safari, is 32 million light years away, or 9.8 megaparsecs. It's called a spiral galaxy. It's sort of an edge-on, so we see a dark lane through the center as we're looking at it sideways. And I don't think we have an object, don't think we have a view of it yet, but we will hopefully.
Yes, we're getting real close.
It was discovered by, can you imagine, one of the Herschels, William Herschel, who probably discovered half of everything in the universe, in 1784. So can you imagine seeing these dim objects with a very meager telescope that the Herschels built in the late 1700s? But they found so many different things and have fathered many different catalogs that we use today, including the first form or first version of which ultimately became the NGC, or New General Catalog. So they've contributed quite a bit to our knowledge of the sky.
And And this is one of those images where stacking is absolutely essential. We're now on our fifth frame, so we've stacked 60 seconds worth of imaging so far, and you can start to see now, I'm pretty sure, that this galaxy is beginning to form. The image that we're seeing right here. I'm going to zoom in a couple of minutes. Um, and you may be wondering, and I'm sure the guys who are more technical probably already know the answer to this, but you'll actually see on the um, on the image that there's a little bit of color variation. I'm going from dark out here through kind of gray and back out to dark here. And the reason this is because I am not correcting for the imperfections in my optical chain. And the reason I'm not doing that this evening is because it's probably number 5 on the list of technical problems that we've had this evening. And so I was unable to apply something which is called a flat to the image, which would have actually have taken this gray gradient out. I'm actually not running with darks either, which is another correction process that I can run, because like I said, very few things are actually running correctly this evening, and we're actually just kind of glad that we're actually managing to image for you folks. I have never, I think, been in the situation where we've literally been having to dry the telescope off with a hairdryer periodically to keep this live stream going. Anyway, here we have the galaxy. I'm going to zoom in a little bit here. This is actually a really pretty galaxy. And we are looking, and I'm going to adjust my histogram so that I can hopefully get a little better look at it here. I'm going to try and bring a little bit more detail. Okay. Need a little bit more. So I'm just moving the white balance and actually the mid balance and the black level to try and get the best picture. And the best picture is typically a picture that's not got too much speckling in it, and obviously shows you as much detail as possible of the galaxy. So here we go. So here we have an edge. So let me just say something about galaxies. So you've probably seen pictures of the Milky Way. The Milky Way is kind of an elliptical shape. It's not quite circular. It's kind of longer in one dimension than the other. It's got spiral arms on it. So when you look down on it, it kind of looks like a elongated dinner plate. However, if you look at the Milky Way from the side, it's got a very narrow edge. So it's got this. It's in 3 dimensions. It's basically it looks like a dinner plate, an elongated dinner plate. So if you look at that edge on, you obviously just see the edge of the plate. And this is what we're seeing with this galaxy here. We are looking right. It's actually a perfectly edge-on galaxy. And so the galaxy extends from about here all the way across the screen to about here. And you can see the central core right in here. And you can see one of many dust lanes that are going to be associated with the galaxy that actually kind of separates the top from the bottom. And I might actually just put this image into black and white, because galaxies actually do typically show a little better in black and white. So I'm just going to drop that into black and white and see if that looks a little... Okay, I'm not sure it does. Unfortunately, because I haven't got my flat supplied this evening, I'm getting a lot of noise up in this area here that typically I wouldn't have. You would actually see this looking a lot sharper against the background. But like I said, at the moment, I think we're just both grateful that we're actually running this evening. So we'll just take what we can get, I think, this evening. Yes, there is. Yeah. Yeah, Dave was just pointing out to me that there's a huge latency between what you're actually hearing and where I am actually in the presentation, it's actually probably running more like 10 seconds this evening rather than 4. But here we have this galaxy, and again, and maybe this is, and actually that is showing reasonably well in black and white, because I'm actually looking at the stream as you're seeing it now. I've actually gone back to color, and it is actually showing quite nicely. And so, like I said, this target is NGC 891, and the distance again, Dave, was
32 million light years.
32 million light years. So we are actually seeing, again, the light coming from an object that left that object 32 million years ago, and has traveled across an incredible distance to get to us. And we're actually picking this up in this small 8-inch telescope this evening, and looking at this galaxy. But again, things could have significantly have changed out there, because the image that you are seeing this evening is indeed 32 million years old, and obviously 32 million years has gone since, or has passed since that light left. So, and things do change out there. And yes, to answer your question, Chris, I am stacking, albeit that initially we had problems with the stacking. Right, so I think we're going to try another target.
NGC 457.
Okay. Okay, we are going to
Cassiopeia.
all right, we are going to try another NGC number, and
457.
okay. Okay. Oh man, NGC 457. So I go to my star map, I select my image, I click this button here, which slews my telescope, and you will see the telescope slew across to this target and then settle on the target. So I'm hoping that when we go back to the camera and we turn off the live stack and we go back out to our full view, and wait for the next frame to come in. So tell me, Dave, what am I looking for?
NGC 457. The owl cluster.
Got it. Got it. All right. Yeah. And so I am going to move this target, but we've definitely got the owl cluster here. Right. So let me just orientate myself here. So I'm going to drop this back a second. Oh, okay. That was interesting. Yeah. Again, for those who are technically orientated, you would have seen that my gain was way up there. And because I am not used to the workflow that I'm doing this evening, I had that gain set wrong for the last object. But no worries. Hopefully I'll get it right this time. Right, so I'm just going to bring this target sort of center screen a little bit. Just bring her, let's see, let's put it across. That was the wrong way. Just let the mount settle again, so I'm just going to bring it down. And Dave, when we get this owl cluster up, I'm going to let you talk a minute, because I am going to put another jacket on, because it's actually getting pretty chilly out here this evening. Alright, so I probably got the owl cluster where I want it in the screen. I am going to change my gain settings again so that we get the best possible image that we can. And normally I would not be doing this. As I said earlier, we have been experiencing some technical problems. Normally I run plate solving, and it really is a slightly different workflow, and it's super quick and so forth and so on, and I don't have to do any of this playing around. But like I said, it's been an interesting evening so far. So such is life.
So the owl cluster, again discovered in the late 1700s, I believe by one of the Herschels. Um, Interesting, has other names. It's also known as the ET cluster, and it is a favorite for when we used to do star parties at school, and we would talk to these third, fourth, and fifth graders. We would show them the owl cluster, and they became very excited because they think it's a picture in the sky. Um, the original description of an owl came from the two bright stars that look like the eyes, and then the outspread wings as if the owl is in flight. So the modern version description for this particular open cluster and asterism, a lot of the boys I've talked to in these elementary schools think it looks more like an X-wing fighter from Star Wars, or maybe an F-18 jet flying in the opposite direction. And that the two eyes would be the afterburners. So it's very interesting that these star pictures in the sky have many interpretations depending on your perspective. But in any event, it is an open cluster. The stars are fairly young. They're about 7,900 light years away. And it makes a good conversation piece when we're working with kids and people that have an imagination.
Yeah, and
How's
also
that picture?
one of the cool things about this particular cluster, as with many of the star-like clusters that we've seen this evening, is that they actually image relatively quickly. So we don't have to sort of sit on them for a long period of time. We can and I'm once again looking at my screen, not responding to anything I am doing. And these images do image quite quickly, so that's good for this type of presentation because obviously we can move through a number. So Dave has once again got the hairdryer out, and we are now trying to dry off the computer here as my computer finally does start to respond a little bit to where we're at. But that's actually kind of a pretty little open cluster. And as Dave said, it does tend to be a favorite with the children. This is one of the ones that my 5-year-old daughter likes to see a lot. Okay, so I think I'm just going to take a chance here, Dave. Do you think I can get to M27? I think we should, right? Oh, I'm not going there. Dave was just saying that if I wanted to get to a target I was thinking of, we might have to do it. Okay, I'm not going to go there then. M30. I want to get to a nebula. Yes. So I am now going onto my star map. Oh, I think I can. Now we're winging it a little bit, but anyway, we'll see. Oh, how about C9? So that's the Iris Nebula, right?
Okay.
All right, let me try that. So we're now going to, we've looked at a number of star clusters. We've looked at a galaxy. So now we're going to hopefully take a look at a nebula. This might not have been the best one to start off with because it's not super bright and I may miss it when I try and because of the alignment problems I'm having here. But we'll give it a shot and see what happens. And if we can bring it up, that will be our first nebula of the evening. And if not, we'll probably try and move on to a different nebula. So we've been going for about 54 minutes here. We've got some fantastic views of the lights of the city of San Diego. I can tell you it's actually quite chilly on our location now. We must be down probably into the low 60s, and it's beginning to feel a bit chilly. And Dave, this is where I may need some help. Do you recognize that?
Let's see.
So we are, the reason we're just hesitating here at the moment is because I've got a half-degree field of view on the telescope, which is pretty minimal. And I'm looking for a relatively faint target, and that target is not appearing currently on my screen. So let me just do one quick setting. Okay. I do not see anything there. Okay, all right. So I'm just gonna move the mount here, and we're hopefully gonna. Okay. So I'm gonna just make some. Oh. No, I'm on C9, right? Oh, if that was the one, I'm. Oh, okay. Sorry about that. We're just getting confused with our targets here. Oh, I didn't really want to do that. That's gonna be a challenge this evening. Okay, so just bear with us 1 second here, and we will go from there as we figure out what our next target. In fact, while we're figuring out our next target, Dave, I'm just gonna, I think, swing onto Andromeda.
Okay.
Because I can't possibly miss Andromeda. Although anything is possible this evening, so who knows? So Andromeda is another galaxy, and is part of the local, what's called the local group of galaxies, which includes the Milky Way. And I've hit it straight away, so that's good news. So I am going to just get ourselves sorted out on this a little bit. I'm going to bring the center of Andromeda into the center of our screen here, and then we can talk about it a little bit in terms of what we're looking at. So okay, so that's going in about the right direction there. And now I'm going to move it down in the image. I picked the wrong direction. You've always got a 50-50 chance of getting it wrong, but somehow those statistics don't seem to work. So I'm just going to shift that down. And Andromeda, the center of Andromeda, the core is what you can see there, is now coming down. So I'm probably going to be happy with that there. Right, so I'm going now to adjust my controls again. And I'm going to start an imaging sequence. So we're running on about a 12-second sub, as I said before. We're going to live stack this. And as I was saying there, Andromeda is one of about 7 or 8 galaxies in what's called the local group of galaxies, which includes the Milky Way. And this is actually a huge target. So you're going to see this image start to form in a couple of minutes. Yeah, it cleared. It's just, everything's just running so slowly tonight. Yeah, it's yeah, Dave is looking at my software. Oh, there it goes. Dave is looking at my software, and I'm clicking like the computer, and it's taking like 5 seconds to react to anything I do here at the moment. It really, I'm actually surprised the stream is still going. I mean, I guess we can be thankful for that. Right, so here we go. We're gonna start letting this image form a little bit, and I'm gonna tell you a few things about it. This is actually a huge target. As I said earlier on, when you're looking at my field of view here, it's 1/2 a degree by 1/2 a degree, which is basically the size of the moon. So we would see the moon fully taking up the screenshot. Andromeda is 3 degrees wide by a degree high. So we are not just looking, we are only looking at the central part of this galaxy. If you could actually see this galaxy with the naked eye, which you can kind of if you go out to a really dark sky site. But if this was a bright object in the sky like the moon, it would be the most dominant thing that we see in the sky. But unfortunately, it's not. So in order to get a good view of it, we actually obviously need to bring out some telescopes and do what we're doing this evening. And Andromeda is kind of a bit challenging to image because it has a very bright central core, which is a massive aggregation of stars. And the outer spirals are actually fairly faint. It's got a very large dynamic range. And I'm going to try and do just a few adjustments here. In fact, I might bring this into black and white because the color looks terrible at the moment. Here, could you try it's the mouse and everything that's just not working here. So we're just drying my mouse off here with the hairdryer. What can I say? Beer, please. Somebody was bringing me a beer, and I'm not sure I've seen that yet. Oh, there we go. So that was the lovely. Oh, so actually we've dried the mouse off, and it's completely stopped working. So hold on a second. I don't believe it. My mouse has stopped working now. Hold on. Oh, yeah, we're back again. I can't believe how difficult this is. Nothing will work. Come on. Oh, Lord. I have never seen the computer do this before. Okay. And you can probably see here as I struggle with these histogram controls. The range, or I was going to say the degree of light variation across the actual galaxy itself, because it's making it actually very difficult to image, and combined with the slow response of everything that's going on around me at the moment. Anyway, all right, so we are not probably going to get the best of images here, but let me try and explain. But we can actually see some stuff that I'm going to try and just point out to you in a few moments here once I've adjusted this just a tad more. And I must apologize for the struggles we're having this evening. This usually goes way smoother. Okay, but here we see the central core right here. And again, all of these stars that we're seeing in the picture, these are stars in our galaxy, in the Milky Way itself. These are not stars in the Andromeda galaxy that we're looking at. All we're seeing from the Andromeda galaxy, because even though it's relatively close to us, it's 2.3 million light years, I think.
About, yes.
Yeah. Even though it's relatively close to us, it's far enough away that the stars, basically the light just aggregates. It's a glow. It's a glow. You can't make out the individual stars. It's too far away. Although I think can Hubble resolve the Space Telescope resolve?
Well, I know we should be able to resolve supernovas and things like that, and
Right.
globular clusters. I don't know about individual stars.
Okay.
Somebody in the chat room may have that answer, but I don't.
Right. Okay. And so we're seeing the central core, and what we're actually seeing around it here, albeit that we're not seeing it too clearly, you might be able to see these lanes. There's one here. There's one going down through here. There's another one just here. These are actually the spiral arms of the galaxy. If this picture was resolving itself much clearer, you would actually see that these are the dust lanes that separate the spiral arms of this galaxy. that is not face on to us. It's kind of tilted at maybe a 30-degree angle or something. So it's mostly face on, but not quite there. Dave's nodding, so presumably I got that right. And what you're seeing here is the dust lanes that go between the spiral arms. But this galaxy is huge. We are literally seeing 1/6 of this galaxy, then that is the center part of it. It actually extends way out in this direction and way out in this direction, and it's a lot narrower in this direction. It's about a degree wide in this direction and 3 degrees wide in this direction here. So that's the M32 galaxy.
31.
M31 galaxy.
Couple things I might add.
Yeah.
So M31 is the closest large galaxy to the Milky Way. It's one of the 3 galaxies in our local group of large galaxies. The third one is M33, which we may be able to see. I'm not sure. M31 is probably a little larger in size than the Milky Way galaxy. It's about 130,000 light years across. And but these numbers are subject to the latest observations, and they change quite often depending on how good our technology is. But we believe it's slightly larger than the Milky Way galaxy. And the Milky Way galaxy and Andromeda are headed towards each other. I think it's sort of urban legend that there's going to be a crash sometime in the future. Well, we don't see it as a crash, but in billions of years down the road, there will probably be some kind of an interaction or a merger of some sort between the Andromeda galaxy and the Milky Way. And it's fun to think about such things because we can't possibly imagine what would actually happen. But we do know that the Andromeda galaxy is moving towards the Milky Way. A couple of things about the numbering of these galaxies. M31 and the small companion galaxy M32. Gary, can we see that?
No, we can't.
We can't see it.
No, we're not going to get there tonight.
M32 is a companion galaxy right in the same field of view as M31. And opposite that is M110, which is a larger dim galaxy that is also a companion to M31. So in Charles Messier's original list of objects that were not comets, when he found M31, he labeled M31 and the small galaxy M32, and in his notes he described and sketched 31, 32, and what we now call M110, but he did not assign the M110 number to that other galaxy. That was assigned later on when someone reviewed his notes and realized that he actually had seen that galaxy and just not given it a number. So it's a matter of discrepancy or argument whether or not M110 is part of the original Messier list. But we do consider it as such, and M110 is the last object in the Messier list. Just wanted to mention that bit of history.
Sure. And while Dave was mentioning that, I have actually just moved the scope. I am hoping that I'm going to pick up M33, which is another galaxy. But if I miss it, I think we will move on to another target because we've seen quite a few galaxies already. And I would like to try and bring a nebula up if we can. So
Let's see what we can find.
let me see if I think I may have got this galaxy. Let me see if we can. Yeah, I think actually I might have got lucky there, Dave, and I think I've hit.
You found it?
Yeah, I think so. Let me just check. Yes, I got it. And again, for those of you that are watching, and as you see these frames stack, you will see this noise disappear to some degree. Unfortunately, it's not going to disappear completely tonight because It's not going to disappear completely tonight because I've not been able to set a couple of the things up in the software that I would normally set up. But you do see the noise stepping away. Now, interestingly enough, I am dropping frames again, Dave. So I'm wondering if we need to
Dry that.
just dry our even though we've got a dew shield on this telescope. With the humidity being so high this evening, I think we're just going to need to get our hairdryer going again here and just dry things off. So while Dave is doing that, I'm actually going to bring up the presentation that hopefully I'm going to bring up the presentation that I started with this evening. And I just want to, the reason I want to do that is for those of you who are not familiar with sort of the distances that we're talking about here, I just wanted to try and describe some of the distances we're talking about here. And all right, okay, come on. Oh, Lord. Okay, so again, I may not be able to bring this full screen because for some reason, full screen on my PowerPoint is not working either this evening. But at least you'll be able to see enough of the screen that you can actually see the slides. So let me just try and see what happens here. So Dave is actually I doubt if you can actually hear the hairdryer, but Dave is actually doing a little bit of hair drying there on the thing, on the telescope, and I am just going to try and get this slide deck to work. Right, so I'm not sure if anybody recognizes this face, but this is Albert Einstein, probably one of the greatest scientists that we have ever had. And Albert Einstein is responsible for many of the theories that still hold true, that is our best understanding of the way that the universe is put together, including what's called the general theory of relativity. One of the things that he defined as part of that was he realized that there's a constant in the maths called the speed of light. And the speed of light is 3 times 10 to the 8 meters per second, which if we talk about kilometers and miles is 300,000 kilometers per second, or 186,000 miles per second. So basically light travels at that speed. It is an electromagnetic wave, and it travels with a fixed speed, and it covers huge distances in a relatively short period of time. So 300,000 kilometers per second, or 186,000 miles in a second. To give you an idea of how far that is, the moon is about 250,000 miles away. So the moon is about 1.3 or so light seconds away. So when we look at the moon, we're actually looking at the moon as it was 1.3 seconds ago. And Dave is perhaps suggesting another target that we could try that in a minute. Yeah. Let me finish this off and we'll do that. Okay, so our sun, which is a relatively insignificant star in the Milky Way. The next closest stars are the group of Alpha Centauri that consist of Alpha Centauri A and B plus another much smaller star called Proxima Centauri. They are 4.3 light years away. So the light that comes from those stars has taken 4.3 years to travel to us. And those are the closest stars to us and on Earth and our sun. And it's estimated that the average distance between stars is somewhere around 5 to 6 light years. So stars are relatively well spread apart from each other. As I mentioned, it takes 1.3 seconds for light to get from the moon to us on Earth. It takes about 8.3 light minutes for the light of the sun, our own sun, to reach us here on the Earth. So as you're bathing in that warm sun on the beach, that actually left the sun itself, that energy left the sun itself 8.3 minutes earlier. And as I said, Alpha Centauri and that group is 4.3 light years away. So I'm going to try and put this in some context now. So the context I'm going to use is the solar system, and I think probably everybody on the live stream hopefully has a sort of feeling of what our solar system is, right? It's our sun around which a number of planets rotate. Those planets start at Mercury and go all the way out to the dwarf planet Pluto, and we're number 4 on that list as we go out. And the solar system's a pretty big place, right? There's a long way between objects in the solar system. But what I want you to try and imagine now is, let's take that solar system and let's squeeze it down to the size of a 1 cent piece. So I've got our entire solar system, so that's the sun, the planets, the 8 planets that are revolving around it, and I squeeze that down to the size of a 1 cent piece. And I put that 1 cent piece on the 0-yard line of a standard size American football pitch. And of course I had to make that correction because, as some of you probably guessed, I'm English, and so when I say football pitch I mean something different. But we're talking about an American football pitch here, and we're going to put that 1 cent piece on the 0-yard line. That grouping of stars that I spoke about, Alpha Centauri, would be 264 feet away, so approximately up around the 20-yard line on the other side of the halfway line. And between us and those stars, I would say there is nothing. That is not actually technically true. There's nothing that we can visibly see. It's dark, empty, cold, the vacuum of space. We could get into more details about what is actually out there, but I'm not going to. But let's just say there's nothing, because that's the simplest way of thinking about it. So between us and our nearest, so us as a solar system, we're this 1 cent piece. And of course, the sun and the moon are tiny, right? They're now specks on this pretend solar system that we have. And these nearest stars are 264 feet away. And that is just 4 light years. So now think about our galaxy. Our galaxy, the Milky Way, is 110,000 light years across. Some of the galaxies that we've been looking at this evening have been 30 million miles away, 30 million light years away. So let's try and put that into some perspective. So Voyager 1, which is the farthest man-made thing from the Earth, was launched in 1977. It's been in space now for about 40 years. It's currently traveling at about 60,000 kilometers an hour, which most people would think is pretty quick. But it's only 17.5 light hours away from us. It's 4 times further away than Pluto. If we were to put that on our little football pitch analogy that we just looked at a few moments ago, that is literally just a few centimeters, a few inches off of the touchline. We have our furthest object from the Earth has got literally nowhere in the sort of overall thought process of the universe here, right? And this is really one of the problems that we have here, is that there could be many civilizations out there in the universe that are all intelligent, that are all capable of communicating with each other, but like us, they are so far away from anything else. The chance of us actually being able to communicate with ourselves is almost zero. It really does kind of put these things into perspective when you start thinking about the size of the overall universe. And one final slide, just to sort of give you an idea of just how big our known universe is. I'll just put this one final slide up, and I'm sorry it's not bigger, but unfortunately my full screen mode is not working here. The size of the observable universe, that's what we can see, is currently at about 13.7 billion light years. So a few moments ago we were talking about 4 light years, and then we were talking about 35 million light years, and now we're talking about the edge of the observable universe being 13.7 billion light years away. So in the scale of things, the things that I've just been talking about, literally we're still back on the touchline here, right? Nothing. We are looking at objects that are right here, right at close to us. The rest of the universe, which is out there, this incredible, immense amount of space that we can see, is so far away, it's almost inconceivable. And actually, when I say it's 13.7 billion light years, that's what we can see. But of course, that light has taken 13.7, or that electromagnetic energy has taken 13.7 billion light years to actually get to us. So the actual edge of the universe is much further out than that, because the light that's coming from that hasn't even reached us, so you can't actually see where the edge is. So it kind of puts things in a little bit of perspective. Anyway, less of the theory and back to the viewing. I just wanted to throw that in. Hopefully Dave has managed to clean my scope off. Oh, and we were just, let me just see if I can reset the stack on this one, Dave, and then we'll think about going across to a nebula. So we're going to take one more look and see if we can get a better view of the M33 Pinwheel Galaxy, and then we're going to take, and did I see a beer?
Yes.
Unbelievable! A lager has suddenly appeared on my desk here. This is incredible. Suddenly the world appears to be a happier place.
Compliments of Mount Helix Park.
Oh yes, please. Can I take one of those? Oh, yes, thank you.
Whichever one you like.
I'll take the pale ale. That would be great.
Either one.
No, I'm good on the pale ale.
There we go.
I hope you heard the hissing of the bubbles coming out of the beer there. Everybody online. Oh, that is so much better. I am feeling a lot happier with the world now. So we're just going to, oh, and here we come. So we're going to just take a quick look at M33 here, which is another galaxy. And hopefully, Dave, if you've got just a few facts for the folks, that would be fantastic. We are only managing to stack at about 50% of our images, but at least we are stacking. So the image is slowly improving. And if we can get a couple more images into the stack here, we will be good to go.
So M33, often called the Triangulum Galaxy because it's in Triangulum, is the third of the 3 large galaxies in the local group. We talked about the Milky Way and Andromeda, and now Triangulum, or M33. So checking facts here, the distance to M33 is about 2.8 million light years, a little farther than Andromeda. And size-wise, it's about half the size of the Milky Way galaxy, about 50,000 light years rather than 100 or 110,000. So a little bit smaller. It has the photos of M33 are beautiful. It has some really bright hydrogen alpha knots in it, and it makes for a great image. It has great circular arms. We're looking at it almost directly onto the spiral, and it's a great image target for astro imagers out there. So let's see. I'm quickly reading here some of the notes about M33. Probably
so just to interrupt you there, Dave, one of the comments from Curtis was, I thought you said bear, not beer. And judging by the way things are going this evening, having a bear or a small mountain lion turn up this evening would not be unexpected. So sorry to interrupt you there.
interesting thing, one of the ways we find Andromeda um, and M33 is the star Merak. And it's easy to find Merak by looking at the diagonal across the Great Square of Pegasus. It points to Merak. When you see Merak, if you in the eastern sky, if you go up a little bit, you see a few stars, then you find Andromeda. But if you go exactly in the opposite direction, going down below Merak, you'll find M33. So M33 is a good object in nice binoculars or in a wide field scope. And so it's not too difficult to find if you have a dark sky. And not as bright as Andromeda, of course, but it sure has a lot of great detail. So
Yeah, and that detail is beginning to show now a little bit on the screen. We are seeing a fairly nice image of the galaxy now. The galaxy is basically face on to us, so we're seeing the dinner plate or the oval shape of the galaxy. And you can actually see quite clearly here the spiral arms. Don't get confused by a couple of the spiral arms seem to run in conjunction with a couple of the stars here. The stars do not belong to M33. These are stars that are in our own Milky Way that we're looking past. But you can see the spiral arms of this galaxy quite nicely on this image going towards the central core. And you can actually see that this galaxy is spinning in a clockwise direction because of the way that the galaxy arms come out and go obviously to the left. So the galaxy is spinning in a clockwise direction. The inside is spinning faster than the outside, and that's what causes the spiral arms to form and create. And a couple of people asked me what the NGC number was on the thing here. It's a PA 394. That's a Paleo 394. So just for the catalog number there, for those who are interested, it is a PA 394. Other questions too. Yes, we've got some funny comments coming in about bears in particular, so thanks for those. And welcome Stephanie, who's just joined to what's proving to be a pretty entertaining evening here. We are once again, for those of you who just joined, on Mount Helix, which is one of the iconic landmarks in the southern part or southeastern part of the city of San Diego. It's several hundred feet high, probably 400 or 500 feet high, I'm guessing. We have a big cross up here, fantastic views towards the East County in particular. But one of the challenges is that we're also pretty close to the ocean. We've got a fairly stiff breeze coming across here as well tonight, and so it's getting chilly, and we've had a few issues with dewing on the computer equipment and the telescope, but we're still managing to run, so that's good. We are we're about 90 minutes into our live stream here. We still haven't managed to bring up a nebula now, so we are going to try for a nebula. So, and then we will explain what that is and hopefully get a decent picture up on the screen. So, okay, where am I going, Dave? NGC 281. Oops, that's not the right number. NGC 281. All right. Are you sure? I've got it as showing as an open cluster. It probably is, right? 281. Okay. Yeah. Okay. So it's a open cluster with nebulosity. Yeah. Okay. Right. So I've just slewed the scope again. We are back in the constellation of Cassiopeia. For those of you who are not familiar with Cassiopeia, it's basically in a northeasterly direction and looks like a big W or M in the sky. I'm actually just showing it on my sky map here. That is the constellation of Cassiopeia. So hopefully, since we haven't slewed too far, I'm hopeful that we will be pretty much on target, and we can hopefully see what's called the Pac-Man Nebula. Alrighty. Okay, so okay, Dave, do you recognize where I am here? Because unfortunately, one of the things that I don't have running on my machine at the moment is my plate solving tool, which allows me to precisely point them out. But I think I can see some nebulosity in there already, right?
Checking the stars.
So let me just throw this on the live stack and see what happens. I'm going to bring that game back down. But I think I can see some color in there already. So let's. Okay. Do I need to move the mount, or are we good?
That's there. I think we're okay. It's probably the same thing as normally here.
Okay, so I'm just going to move the mount then. Let me just move the mount across a little bit so that we can get it a little
So it is
more center.
35 by 30 arc minutes.
Okay.
About.
All right, so I am. Okay, so that's bringing. So I'm just trying to position the mount a little bit more accurately. This is a little bit of a challenge because we can only use these stars as our markers here. So I'm kind of hoping that we. Okay, so does that look better, Dave? Just give us a second here while we check our star maps. Okay. This one up here. Yeah, okay. All right. So I am now going to change my stacking parameters again and see if we can actually start to get something going here. And while we're waiting to see if that works, Dave, do you want to just say a few words about nebula?
So in general, we look at these nebulous clouds out there, and it's part of the interstellar medium that is a higher concentration, and a lot of the content of that medium is hydrogen, either atomic hydrogen or molecular hydrogen, and which is the most common element in the universe. So these star clouds, cold dark clouds, will begin to form, and if there's enough a little bit of gravitational effort to bring them together, to make them more concentrated, at some point in time this cloud may be struck by some kind of a shock wave from a supernova or some other event, which would then begin the formation of new stars, because that shock wave causes plus the gravitational effort causes a condensing of the star matter enough to actually begin to fuse hydrogen into helium. So this is where stars are formed. They're formed in clouds of gas, much like this Pac-Man Nebula or the Orion Nebula or many others, where the nebulosity is struck by a shock wave. The star formation begins, and we see that there's a lot of stars begin to form inside that cloud. And as those stars form, they begin to consume the available material, the interstellar medium around it. They consume it. They bring it into the stellar disk, and eventually those disks can become solar systems around new stars. So what we see in these clouds are groups of very young stars. Sometimes they're as young as 10,000 years old, or less than 100,000 years old, and then we see these stars inside that cloud. And as I said earlier tonight, those stars, when they consume that cloud, ultimately become an open cluster. But what we see with the Pac-Man Nebula is that star-forming region, a cloud of gas, and it's in a different phase or different state of early star formation. And this the clouds of gas can be ionized by the stars around it, make them glow, so it's an emission nebula, or it could reflect the light from a star and become a reflection nebula. I have not studied the Pac-Man enough to know how much of which is there, but that's the two common ways that we see the light from these nebulosity. Do we have any image yet?
Yes, we do. So we have an image forming. Unfortunately, it's not the best of images because I don't have a flat applied which would correct it. But we are seeing the nebulosity. We're seeing the shape of the Pac-Man Nebula, which I guess in part got its name because it's kind of circular. So we're seeing the sort of circular shape of the nebulosity, and we're also seeing some of the dark channels that run down through the Pac-Man Nebula. We're fairly well centered. We're a little bit low, but we're not too bad. So in fact, Dave is saying the center is near the top of the image. Yes, well, yes, that's probably true, Dave, because everything's been going wrong this evening. But so it looks like we've got the bottom of the Pac-Man here. I could potentially try and move it down a little bit. Let me see. Oh, okay. So Dave is just showing me. Okay. All right. So let me just adjust things a little bit. Let me see if I can pull this down a tad and see if we can. Probably need to turn the live stacking off for that. Okay. So if I can pull this down a little bit, we might get a better view. Okay. So I got the mount. Yeah. Here we go. I'm just going to move the mounts. I'm going to move the image down here. Okay, so let me try that. So I think we may be a little bit more. So I'm going to turn my stacker on again. I'm going to clear it, and we'll just let this image stack again and see if we can get a slightly better representation of the Pac-Man.
76.
Okay, so one of the questions that came through on the feed, and I must admit I'm not having as much chance as I normally would to look at the feed with all the problems that we've been having this evening, is what would it take for Gary's setup to turn it into Planetary? And yes, you may have noticed that we're not actually looking at any planets, and we do actually have a couple of planets in plain view at the moment. Mars is particularly impressive. It's actually at almost one of its closest approaches to Earth, and it's actually very high in the sky this evening. We do have Saturn and Jupiter that have dropped behind me to the west now. But the setup that I have here is actually, and I'm dropping frames like crazy, so I just need to quickly reset something a minute. Hold on. So let me try and reset that stack. Right. So I was saying, so the I've lost my train of thought now. I was on planets. So yes, in order to turn this into a planetary viewer, I would basically need to take out the focal reducer. I would put a Barlow in, which is a magnifying device. And by taking the Barlow, putting a Barlow in and taking the focal reducer out, I would actually, my field of view would go down by a factor of probably close to 4. Which would allow me to get much closer to the planet itself. I would then video the planet for probably capture about 5,000 or 6,000 frames of very quick images, and then I would run them through 3 different software packages, and at the end of it we would come up with a pretty good rendition of what Mars looks like or whatever planet I was looking at. Unfortunately, the possibility of that happening this evening is absolutely zero. So, not only that, but we couldn't do the hardware change anyway. But so no, this evening we're just going to look at deep sky objects, or DSOs as we like to call them. I might, if you're interested, I could swing the scope onto Mars and we could just take a single snapshot and see what it looks like, but you won't get much of an image, so it's probably not worth doing. So we are actually much better centered on the Pac-Man now, Dave. So we're getting there. I'm not expecting great things in terms of actually seeing a huge amount of detail, as much detail as I normally would. And in fact, what was the number of this one again, Dave? NGC number?
Yeah, I forgot. Hang on.
We're just going to check the NGC number a minute. Because one of the things I do here is, as I'm imaging, what I normally do when I'm imaging is that I will normally type the target name in up here. 281. Okay. I'll normally type the target name up here and actually save the images, and that way I've got a record of what I've seen, and I keep the best ones. So let me just go back into my target database here, assuming that my computer will actually even respond, which is, I think I'm going to, oh, there we go. Let me see if I've actually got 281 in here. NGC, just need to probably order that. I think I'm going to need the hairdryer myself shortly, Dave. I'm beginning to freeze to death out here. But anyway, we'll just keep going until I fall over. No, I think it was the beer. I think the beer has actually made me quite cold now. But anyway, so I will bring up a picture of the Pac-Man Nebula that I actually shot probably within the last 3 weeks. And Dave is now judiciously applying the hairdryer once again. As long as you don't hit the beer, Dave, that will be fine. Oh, so here is a slightly better rendition of the Pac-Man Nebula that well, I mean, you can certainly see the shape, but this is a slightly better image of the Pac-Man Nebula that was taken a few weeks ago from a different location. But actually, even this one is not fantastic. It's not a bad image, but it's not fantastic. What we're actually capturing on the live stream is actually fairly decent. So let me close that down again, and we'll go back to our live stream, because I'm sure you came here to view a live astronomy event, not me going through a series of pictures on my PC. Okay, so we still have 140 folks online. I really appreciate you guys sticking with us through this. I know it's been kind of a slower evening than we would normally anticipate. I can usually get through about 10 to 12 targets an hour, and we're struggling to do 6 to 7 at the moment. So I really appreciate you guys hanging in there and sticking with us. And so I think we're probably getting close now to doing almost our final target of the night, Dave. The little dumbbell. Okay, so let's M57. Oh, 76. Okay, let me see if we can. No, I think you're right. I think it's M76.
Yeah, 76.
76. Okay, we're fairly close to that. So let's go find hopefully a planetary nebula, which is a different type of nebula. Okay, good. I thought my live stream had gone offline there, but apparently that was just a slow reaction from the broadcast software. So we're now moving on to what's called a planetary nebula, and Dave will explain that to you more in a few moments. First of all, I'm going to see if we can actually find it. That would be a great start. So let me just adjust things here, and I need to turn that off. So I think we looked at the Pac-Man there. Yes, and we've actually managed to get lucky. I can see the target in screen, so that's good. So let me just move that towards the center now. Nothing is working here. Come on. Oh, there we go. Right. Okay, so we're just moving. I'm just moving this, doing a little bit of tweaking on the position of the target, which I can actually see on the screen. You may have spotted it yourself. I'm sure those familiar with this particular target will have already spotted it. For those of you who are not familiar with the target, I can assure you it's there, and we will hopefully get a little better view of it in a couple of minutes. Right, so we've almost got that into the center, and for those of you, because of the marvels of modern technology, I was close. I was pretty pleased with that. I'm pretty much in the center there, so I will turn that off. And we will now try and stack this target, which is a planetary nebula, and will probably be our last target of the evening, because I may not make it past 10 here.
So while that's developing, Gary, can you hear me?
Yes.
Okay. I'd like to give a shout out to Krista Powers, who is with us tonight and has stuck by us faithfully, providing hair dryers and recently some enjoyable libation here to keep us going. And so thank you very much, Krista. She's the executive director of Mount Helix Park, and she's been working with us for some time to try to put this project together. So it's finally here, and it's really great. Did you want to say something? If you do, lean close.
Dave, and I just got to say you guys are incredible, and thank you so much. And you know, we do an astronomy night every single year with the San Diego Astronomy Association, and we normally have about 800 people plus in the park. And so it's just amazing that you guys figured this out, how to provide it to everybody at home. So I hope you're all enjoying, and thank you so much. And if you live close in San Diego, come and visit us or go to mounthelixpark.org. And we are not supported by any other funds other than our community donating to us and volunteering with us. So thank you so much for coming.
Thank you, Krista. So we're waiting for the planetary nebula to appear on the screen. This is called the Little Dumbbell because it is looks like a smaller version of the Dumbbell Nebula. These are planetary nebulas, so many of you may not know what a planetary nebula is. It is quite different from the nebula, the Pac-Man or the Orion nebulas where we talked about star formation. Those nebulas involve the beginning of a star's life, the birth of a star. But a planetary nebula is evidence of the death of the star, the end of its life. Most stars on what we call the main sequence, medium-sized stars, something like our own sun, they survive mostly on hydrogen gas, which is fused into helium in the core of the star. And the hydrogen gas is cycled through layers of convection layers to bring the gas into the core where there's enough heat, enough pressure to create a fusion reaction. When that fusion reaction occurs, the helium stays in the core because it's heavier than the hydrogen. And the more hydrogen is cycled in, and the fusion reaction causes a release of heat and light, which helps warm our Earth and brings light and heat to our solar system. So this continues until the hydrogen fuel begins to run out. And as that hydrogen fuel begins to run out, the fusion reaction stops. So when that fusion reaction stops, in the core of the star, there's no outward pressure to push out against the gravity of the heavy core. So the core collapses. When that collapses and the fusion stops, the outer layers of that star then begin to expand into the neighboring universe, into a big ring of hot gas, which emits a lot of light or reflects light from the center of the star. And ultimately that center for most medium-sized stars, becomes a white dwarf. The outer clouds then expand into the space around it, and it reflects the light from that white dwarf, and sometimes it actually is ionized and creates its own light. So what that happens is we see a donut shape or a cloud of gas around that bright white dwarf, and what we see is these colored gases around the star, and we call this a planetary nebula. The name is confusing, but when they were first discovered and described, the astronomers knew that these things had some shape, and they had some dimensions to them larger than a pinpointed star, so they thought they were planets. But then they realized they were not moving in the sky like planets do, and eventually they discovered that they were actually nebulas. One of the interesting things about some of these nebulas is in the mid-1800s, the early efforts to do a spectroscopic examination of these nebulas revealed that they were emitting light in the oxygen and hydrogen ranges in great amounts, much different than in a star, where a star has more of a continuous spectrum. These had large emissions in the O3 and the H alpha range. So that spectroscopy examination proved that these particular objects were not stars or star clouds. So this one here is the Pac-Man. This one here is the little Dumbbell.
Yes.
And I want to take a look at it quick.
Yeah, we've actually, the image is actually formed reasonably well now. And yes, Curtis, my black level was way too high. I am not using my normal workflow here because my plate solver is not working. And consequently, I'm doing what Mike often does, which is manually move the target in, and in order to find the target in the first place, I put the stretch on, and if I put a stretch on the histogram and forget to switch it off, which I did, the black level will indeed be too high. So I've managed to correct that now, and we're actually seeing a reasonable rendition of M76 here, the little Dumbbell. You can see the Dumbbell shape. It's quite rectangular in terms of the central bright piece of this. But if you look really closely here, and it's not showing up greatly tonight, but on a better evening, this would actually show quite nicely. You can actually see the shock waves, the circular shock waves going out from the star that's ejected all of the matter in the center, and the star is right here in the center of the Planetary Nebula, and I think we are actually getting a look at that star. It's just beginning to form in the stacker now, so I think that is actually the star associated with the Planetary Nebula. And this, you can see this going out in a circle. In fact, it's going out in a sphere because it's going out in all directions. So this would appear like a bright star with some central bright material nebulosity around it, which is green and red. And then around that is this expanding spherical green sphere that you can just make out in the picture here. Okay, and as Dave said, impressive without flats. Yes, yeah, without flats and darks tonight, which would definitely make this image even better. It is one of the nice things about the imaging camera I'm using. This is a relatively new chip. It only came out probably within the last 12 months. And it's actually pretty good. It's not the biggest of sensors. It's 11 millimeters by 11 millimeters. And welcome Josh, who's obviously just joined. So it's not the biggest of chips, but it does have some fairly good properties about it. And for a color imager, I'm pretty pleased with it. So we are now at 10 o'clock. I will try one more thing, And if we get lucky, we get lucky. And if we don't, then this is going to be the end of the thing, because I am really chancing my arm now. So you may not know it, but um, we well, in fact, I mean these things are happening all the time, but you don't see them because they're so faint. As Dave mentioned, one of the things that really creates one of the most cataclysmic events in the universe is a supernova, which is basically when a star completely explodes. Not like a planetary nebula where the star has actually still managed to maintain part of its core. Here we're talking about a star that has completely blown itself to pieces. Supernova in our own galaxy are fairly rare, so we don't see them very often. But because there are so many galaxies out there, billions of galaxies beyond our own, there are astronomers that hunt for supernovas in other galaxies. And there was a recent supernova in galaxy NGC 7722, and we are going to go and try and take a look. Now, the trouble with this is that the galaxy itself, which is 183 million light years away, is extremely small and extremely faint. And the supernova, which we will hopefully see, is pretty small. But I mean, the big problem here is going to be actually hitting the galaxy. And the trouble is, if I don't hit the galaxy on this slew, I have got no reference to go look for it. So we're just going to take potluck here because it's the last part of the evening. And I want to go home shortly. And actually, that's a nice formation. That is actually a decent picture now of M76. Now, I'm just looking at the feed, which is running a little bit behind. So I'm going to slew my telescope over to NGC 7722, and we're going to make this the last target of the evening. Now, I suspect that very few of you have ever seen a supernova. These things are fairly rare. Mount Palomar, which is about 30 miles to the east of us, there is a facility there called the Zwicky. Yes, the Zwicky Transient ZTF, and they hunt supernova, and they found this particular supernova on September the 6th, and so it's only been visible now for about 6 weeks. And again, think about this, right? It's been visible for 6 weeks, but this is light that left the galaxy 183 million light years ago, because it's 183 million light years away. So pretty incredible that we can actually see something that far away that happened that long ago, and that's before the dinosaurs, right? So kind of really cool. The big question is whether I'm actually going to even hit the target. So let me see if I get lucky here. So I have been probably, if I look at this sky, I've been like high and right practically on every target, right, Dave? So
Yes.
I probably want to go a bit down and a bit left. So let's see if I get lucky. So like I said, this is going to be our last target of the evening. If you guys want to hang around for this, fantastic. This is probably one of the few chances you'll get to see a supernova. If you guys are all done, thank you so much for joining the stream this evening. It's been fun. We've had a lot of fun out here and bringing this to you. And I'm just trying to get my mount to slew, which nothing seems to be. Oh, there it goes. Oh, right. Okay, so that got me the left part. So now I need to go down. So let's see if I can come down. Okay, that was up. So that was the wrong direction. So let's come down. So we're going to see if we can get lucky here. And if we do, great. And if we don't, then like the rest of the evening, really, it's been fun. So let me just bring this down a little bit more. And I am going to definitely, I will set your expectations now. This is not going to be the most spectacular of images. So, you know, but considering how far it's away, I'm not sure that you can expect too much. So we'll give it our best shot. We'll give it one quick go, couple of frames. Like I say, if we get lucky, we get lucky. If we don't, we're all going home. Right, so let me turn my live stacker on. Take a sip of beer. And hope for the best. And I can tell you, it's definitely getting chilly up on the top of Mount Helix here this evening. But the view is actually pretty spectacular. So now I am going to be looking. Well, let's see how this goes. We may have got lucky here. Luck may be with me this evening. I can see a galaxy. There is a galaxy right there. That's kind of the size. Yeah. Dave's quickly checking his star chart here. When was the last time you saw a supernova, Dave?
The last time you showed me this one.
Oh, okay. So Dave has seen this one before. So that was a level of anticlimax that I really didn't need this time of the evening. But anyway, let's see if I can zoom in here. Okay. All right. There is a galaxy here. So, and to quote a famous Star Wars thing, in a galaxy far, far away. And we've still managed to keep 123 people online. So clearly there's 123 people out there who have not seen a supernova.
But they're finishing their first six-pack.
Oh, okay.
And there's appear to be some romances connecting online.
Some romances.
Oh, really? Wow. Okay. All right. So.
Yeah, Dennis and Astra Janine.
Oh, Astra Jenny. Yeah, I know them both very well.
Oh, okay.
It's a lot of fun.
Okay, guys. So we are heading. We're heading in the right direction, but as I said,
Oh, look at that.
this is not going to be spectacular. Okay, so you're going to have to bear with me here, and this is going to take a little bit of belief. Dave's now decided he wants to use the hairdryer once again on the telescope to see if we can get a better image. So let's see if that works, Dave. I can tell you it probably isn't, because this is a very small target. So Dave is actually just there with the hairdryer, but I can actually tell you that we do have the galaxy in view. This is NGC 7722 for those that are interested. If you want to actually look this up, there are a few places on the web that actually describe it. It's, to be perfectly honest, it's one of those galaxies that doesn't get a lot of coverage for obvious reasons. It's extremely small and a long, long way away from us. Although, again, going back to our PowerPoint presentation, this is 185 million light years. That is only a fraction of the distance to the edge of the visible universe, of the observable universe at 13.7 billion light years. So again, just keep that in perspective. Okay, so this image is, we are stacking. I think we're probably good, Dave. Let's just see if we can pull a little bit more out of this. I'm going to blow this image up a little bit. Okay, so here is our galaxy, and unfortunately you guys are going to have to, I will show you another image in a couple of minutes that I shot a couple of weeks ago that will show this a little bit more clearly. because I don't want you to walk away thinking that you haven't seen a supernova when you actually have. But here is the galaxy, right here. And you can tell this is a tiny galaxy, right? Because if you look, you can see the individual pixels of my camera showing up here. So we are literally probably, this is maybe 20 or 30 pixels wide. And this right here, this blob of color, this a bulge on the side is the supernova. And what you're actually seeing there is light from the star that has exploded. The rest of the light coming from this galaxy, because it's so far away, you can't make out the individual stars. But this blip of light here that we're struggling to see is actually the super. So let me see if no, keep going, Gabe, because the warmth is nice. Just even if it's not doing anything for the mouse, it's warming my hand up quite nice. Oh, I've now got. This is the most ridiculous astronomy session that I honestly have ever done in my life. It's been hugely entertaining, but we are definitely suffering some challenges here. So, all right, keep our fingers crossed. Okay, so we are making progress. I've got the image up. Apparently, somebody was saying that we may have lost the feed. Okay, so here is the same image from a couple of weeks ago. And this one's shot in black and white. And you can clearly on here see the galaxy. And you can certainly more clearly see the additional point of lights here. And that is the supernova. And I can't remember what the supernova designation is for this one. But if you go out, there is a web page that tracks all of the supernova that are currently taking place. And there are many, probably several a day, but not in our galaxy. These are all in the millions of galaxies, billions of galaxies that are actually out there. So this is the supernova in NGC 7722. And I think we are, yes, you're right, Lester. I was just opening the file there. And as Dave rightly said, it's Supernova 2020 SS, try that again, SSF, Sugar Sugar Fox. Okay, guys, I really appreciate everybody participating this evening. We've had a great deal of fun out here. We will... Dave, do you want to say a few words before we finish, and then I'll close
I want to thank you, Gary Hawkins, for putting this program together, and for the last many weeks and couple of months, you've been working hard at developing these protocols to get this online. And sharing it with all of us here at SDAA and all of the members and guests that we have on board. So thank you, Gary, and thank you very much, Krista Powers, for your hosting this event here at Mount Helix Park. It would be great if we had nice dry weather here and we had a camera that we can show you the fantastic views in every direction from this beautiful park. So anyway, that's what I have. Thank you all, and thanks for participating.
No, fantastic. And like I said, it's been a tremendously fun evening. I'm glad we managed to get up here a couple of hours ahead of time because we needed that time to sort out the problems. Our appreciation for Mount Helix Foundation for hosting us this evening, for the beer, which was very appreciated. The hairdryer, which has literally saved the event. Had we not had the hairdryer, this would have been a disaster. So appreciation for that, and fantastic. We will, please look out for us on another live stream, either under the SDAA banner. I also live stream as well from my home fairly periodically. You can find that information if you just search my name, Gary Hawkins, EAA, on YouTube, you will find my YouTube channel and see some of the streams that I've done in the past as well. And we've still got 111 people on board, which is absolutely incredible
Wow,
for
that's
this time
great.
of
Thank
night.
you.
So absolutely fantastic that you guys have been here. And I will, with that, close the stream down and say a fantastic good night and thanks for joining.
And thank you, and clear skies.
Clear skies from San Diego Astronomy Association on Mount Helix. It's okay, I haven't closed the stream down yet because it's going to take the computer like 15 seconds to respond.
It's still live because it won't
I'm
shut
still
down.
live, guys. I'm trying to get the computer to close down. I may actually have to just close the top here in order for this to go dead. Let's see. I appreciate the comments coming through here. And thanks for... Oh, we still got 110 people now, and we're like 15 seconds past the end of the stream. Oh, my word.
That's great.
Okay, well, I am... You know, and it is kind of funny, guys. We are not going to be able to close the stream down at the moment. It is just not giving... My computer is not giving me control of what's going on here. So I am just going to hit the browser and just start closing things down now in the hope that that brings the stream down. It's kind of the hard reset. I don't know whether it was... Well, it was a fun evening. I must admit. That's
sort of like the outtakes that you never see on the TV shows.
Yes, it's... Yes, absolutely. And I'm still not sure. We still may be live here. I mean, this is crazy. I've closed down everything here, and I am still... This thing won't go offline. This is truly unbelievable. All right, I gotta see if I can close this stream down. Okay, guys. Oh, I'm still live. Yes, thanks for that, Curtis. We are trying desperately to close the stream down here, but we have just lost control from my main computer. So I'm gonna try and log back onto YouTube and see if that will work here. Okay, so according to that, I'm live. So I need to... Alright. Okay, so at least I've got some control back of the computer here. Oh my word. How do I close this down?